So let's learn about chi-square tests, which is used for comparing two categorical variables. So the idea of chi-square test is you want to compare the observed versus the expected. So observed is your real data. So let's say we're interested in men versus women and whether they saw, I don't know, the Barbie movie first or Oppenheimer first. So in your real data, let's say you have 10 men watching Barbie, 40 men watching Oppenheimer first. And then for women, let's say we have 45 versus 5. Again, this is real data. So if there were no difference in terms of movie preferences, what would the expected distribution be? So again, we're assuming there's no gender preferences for these movies, so we would actually expect them to be evenly distributed. So it would be 25 Barbie for men, 25 Oppenheimer for men. Same thing for women, it should be evenly split between Barbie and Oppenheimer. So to calculate our chi-square statistics, it'll be the sign, which is chi-squared. It is equal to the summation of the observed minus expected squared divided by expected. And then in our example, it would be, let's see, 10 minus 25, that should be 15 squared divided by expected, which is 25. Let's see, 40 minus 25, that's also 15 squared divided by 25. 45 minus 25, that's 20 squared. And then finally 5 minus 25, that is 20 squared also. And then you can calculate this, and then you'll find that this will be greater than some critical value, which you'll get from a reference table. And you'll find out that there is a difference. There is a difference in movie preferences by gender. The basic idea is chi-square test for two categorical variables. You have a random distribution if there is no preferences, and then you compare that to the observed data distribution, and if the distribution is much more different than the expected, then you consider that statistically significant.